In the previous part of the lecture, we learned about in order for your module to satisfy the modularity criterion, you have to make sure every feature in your module must be specified with clear, complete, and precise interface using contracts. So that's exactly the purpose of this lecture here. Especially, we'll learn about how to write complete post conditions. But in order to do it, we have to know how to use the old keyword in the post condition to relate the pre-state value with the post-state value. But in order to learn about the old expressions, you have to learn about how to copy objects so you can write your post condition appropriately. That will be the line of story we'd like you to follow for this lecture. As usual, let's see what the learning objectives are when you complete this lecture. Number one, we'd like you to understand the 3 levels of copying objects: reference copy, shallow copy, and deep copy. Number 2, we want you to know how to use the old keywords in the post condition, combined with some object copying. We'll see how exactly these two will interplay together. And then the final item will be to write the complete post condition using logical quantifications, either universal versus extension. That's something you have to make a judgment to see which one to use. We'll see concrete example of applying all these together at the end. Let's start with part 1 about how to copy objects with the 3 levels. Let's start with some context information about some running example that we would like to use for the first example. Let's say there is a general class called C, and C can be any class, can be person, can be account, and then there are 2 object variables, C1 and C2, of the same type. So we're going to use C1 and C2 to see how we can do copying. And let's say there's only one attribute called A that's in the class of C. And A in general could be of type primitive, like an integer, real, or Boolean, or A could be of type reference type, like a person, account, etc. But for simplicity, let's assume C1.A and C2.A, they are simply reference objects. But you can later on generalize the mechanism into primitive types later. Okay, but for now, let's just say reference type for A. So this is the starting diagram for all the 3 levels that we're going to introduce to you about object copying. Let me just talk about this diagram very quickly, and then I'm going to annotate for each level when we do the specific copying. Basically, C1 is a variable that stores the address of an object of type C. That's why I visualize this way. And this particular object of type C contains an attribute A. And A is a reference type, so it further points to another object. So I simply put a cloud over here. That simply means the object structure for C1.A can be arbitrarily complicated. Okay? It could be just another single object, or it can be another single object which points out to another single object, and etc. So it can either be it can just be recursive. It can be as complicated as needed. And also similarly, let's say for C2. So for C2, C2 also points to an object of type C. And then its attribute A also points out to another cloud over here. And again, the cloud can be arbitrarily complicated. So that's our starting ground for explaining for the 3 levels of object copying. Okay, so let's now start with the first level of copying, reference copy, by using the common example that we just talked about. So this is how you write a reference copy. So let's read this particular syntax here. So this colon equal means variable assignments. On the left hand side, this is so-called the targets of the assignments. On the right hand side, this is the source of the assignments. What I'm highlighting here simply C2, which is referring to some reference object variable. And C2 here is a reference copy of C2, meaning that we're going to get its address and store to the targets of the assignments, right? And effectively, we're going to redirect the links when we visualize the object diagram. I'm going to show you that on the iPad in just a moment. Okay, so it's going to copy address from C2 into C1, and then both C1 and C2 afterwards will point to the same objects, and this is what we call aliasing, because now they point to the same objects. So whatever change you actually make on C1 is going to also be visible by C2 and vice versa, because they actually can see the same objects. Okay, so now let's see exactly how this aliasing is going to happen on the illustration. Okay, so now again, let's understand this syntax over here. So C2 alone is the reference copy. It's going to copy the address of C2. So C2 actually currently stores the address of this particular object over here. And then we're going to modify wherever we're going to modify where C1 is pointing to, right? Because wherever C2 is pointing to, which is here, and now we're going to store the address into C1. So now what's going to happen is C1, rather than pointing to this particular object over here, so C1 is now going to point to this object over here. Okay, so hopefully you can see that. It's really important to see because we are modifying C1. So that's why C1 should be redirected, but not vice versa. A common misconception could be, alternatively, you might think what this will actually mean is C2 is actually going to change its direction and point to wherever C1 is pointing to. That's actually wrong, because C1 is actually the target of the assignments, not C2. So if you have trouble with this, which is kind of a cover from the previous course, let me know. I will help you with that. But hopefully now it's sufficient. So that's about the reference copy. And then let's see aliasing. Okay, because now C1 and C2, they are actually pointing to the same objects. So let's do some checks to verify some properties. Let's say number one, if we say C1 equals C2, and don't forget, so since now we are in a different language, so equals, a single equal means equality. We're basically comparing the value that's stored in C1 and the value that is stored in C2. Because they point to the same objects, so the equality should be true. So you can see C1, which has been redirected, is now pointing to this particular object, and C2 is now pointing to still itself since forever. So now they are pointing to really the same objects over here. So that's why C1 equals C2 should be true. Okay, no question about it. Let's see, what about their attributes? What if I say C1.A equals C2.A? Should this be true or false? Well, you can see how useful it is to actually visualize what's happening over here. So once you see the diagram, it's actually quite straightforward. Let's see this. In order to see C1.A, you can see C1 is pointing to this particular object here. .A is referring to its attribute A. .A is now pointing to this particular cloud over here, right? That's C1.A. And then how about C2.A? C2 is here, which is pointing to this object over here. And then when you say C2.A, it's pointing to the same A, referring to it. And so it's really about the same link, which is also referring to the same cloud. So C1.A equals C2.A should also give you true. Okay, hopefully everything makes sense about reference copy. As you can see, reference copy is very cheap in terms of the running time and also space requirements. It only takes the copy of a single address and store it somewhere. So I should really make a note, it's the cheapest operation you can do. Of course, correctness should be always your number one concern. So you don't necessarily have to use the reference copy always. You use it when it's appropriate to do so. That's why we also have to introduce to you another two levels of copy in case they are more desirable. Okay, so that's about the reference copy. So now let me go back to the slides, and you will see that's exactly what I just illustrated. You can look at the final outcome over here, but if you still get a question about or trouble about understanding why we have run into this final outcome, rewatch the recorded illustration on the iPad. Let's now go to the second level of copy, which is called shallow copy. And the shallow copy goes like this. Okay, again, we have the same assignment structure over here. So now on the right hand side, you can see rather than just saying C2, we say C2.twin. So C2.twin on the right hand side as the assignment source represents a shallow copy of C2. So shallow copy is going to take a little bit more resources than reference copy. Okay, if you recall back in your object-oriented programming course in Java, we talk about the concept about copy constructor, and the way you define a copy constructor is manual, which means you can manually tune to what extent do you want to copy the objects. If you want to make complete composition, That means you have to make sure there's no aliasing what happened at any level of your object structure. That kind of corresponds to a deep copy. But now we're talking about shallow copy. It's kind of somewhere between the reference copy and deep copy. That's why you have to be very careful. Anyway, my point is, in IFO, you can use C2.twin for shallow copy, and later on we'll see you can also use C2.deepTwin for deep copy. Which one do you want to use, or reference copy, is up to your need. Okay, let's see exactly how this will do, and then we'll see illustration. Let's see some definition. To really create a shallow copy, you simply create, first of all, the shallow, eventually you want to copy the address of C2.twin into C1. So we want to know what the object is for C2.twin, the shallow copy. So the shallow copy is just invisible from the user, just behind the scene. Let's just call it C3, just for convenience. But C3 is never revealed to the user. It's only manipulated by the runtime mechanism of your programming language. So create a shallow copy here. Just create a brand new object, basically. So the brand new object also contains the attribute A. And then, how do you actually initialize this shallow copy C3.A? How do you initialize that? The way to initialize it, simply just reference copy. Again, we go back to the reference copy. However, notice that the difference between a reference copy and a shallow copy is like this. For the reference copy, you don't create any new objects like in a shallow copy. Okay, that's the critical difference. But in the case of shallow copy, even though you create a new objects to begin with, but for every attributes from then on, you still do reference copy. Consequently, you still got aliasing for all the attributes. We'll see visually what this really means. Okay, that's how you can think about how the mechanism will work. So C3.A, the shallow copy's attributes, should be a reference copy of C2.A. C2 is whatever object you want to make the shallow copy of. Okay, and again, we're going to have aliasing as well. So now, can you picture in your mind how the aliasing is going to occur? We're going to see that. Okay, let me switch to illustration. So now, let's talk about shallow copy. Let me start with by saying C2.twin. If you write this particular expression here, that means you want to do a shallow copy of C2. And then, how does this happen? First of all, let's create this particular shallow copy. Let's just call that C3. Okay, whatever the shallow copy of C2 is, let's call that C3, which is invisible. For the shallow copy, you always create new objects. So C3 is now going to point to a new object, also of type C. And of course, it contains an attribute A. But now the question is, how should we initialize C3.A? According to our definition on the slides, we say C3.A. Let me move it a little bit to here. So according to the definition, C3.A is going to be just a reference copy of. So now we're trying to create a reference copy. We're trying to create a shallow copy of C2. So C2.A will be the source for initializing C3.A. So what does this mean? So that means over here, let me erase this. So C3.A is referring to this particular slot, and then C2.A is referring to this particular A, which is talking about this particular reference link. So you simply copy the address of this link to C3.A. So diagrammatically, so now it is going to point to this particular we call the first level attributes. So the shallow copy does create a new object. However, starting from the first level of the attributes, i.e. A, you're actually going to make reference copy still. So shallow copy is not too much more expensive than reference copy. You just need to take the space for the extra objects for the shallow copy. Okay, that's the first step. And then we also have to execute this particular assignments over here. So now C1 again is going to change its direction. So C1, rather than pointing to the original object over here, is now going to point to the shallow copy. Like that. Okay. Again, C3, you can think about C3 is really invisible from the user. So C3, you don't have to worry too much about it. It's mainly C1 and C2 we have to worry. Let's do the same property checks that we did from the reference copy and compare. Okay, let's start with number one. Let's say C1. After the shallow copy, let's say C1 equals C2. Should this be true or false? Okay, let's see. This might be slightly trickier than the previous one, so that's why it might be worth our attention. So now let's see, C1 is pointing to this particular shallow copy object, which is guaranteed to be a separate object. That's exactly the definition for the first step for shallow copy. And C2 is actually pointing to this particular object over here, so they are guaranteed to be separate. So now when you do this comparison over here, that should be false. And this is already a difference from the reference copy, because if you remember, this particular check here, C1 equals C2, is actually true in the case of reference copy, right? So now let's do the second check. What if I try to check? If I say C1.A equals C2.A, so now should it be true or false? Okay, according to the diagram, it should be true, but let's see why. So now for C1.A, it's basically C1 over here .A is now referring to this particular cloud over here, versus if I try C2.A, so C2 is referring to here, different objects. However, because of this first step of the shallow copy, we actually, because of this second step of the shallow copy is guaranteed, all the attributes at the first level already got aliasing effects. So it's now pointing to this particular cloud. Okay, so this will be true. And this result over here is consistent with, you can see C1.A and C2.A for the reference copy is the same. So now you can see reference copy and shallow copy, they share some similarity. They got aliasing for sure. However, they do have some difference, which is the objects themselves are not the same, because you always create a new object for shallow copy. Okay, hopefully that makes sense between reference copy and shallow copy. We're gonna so here we are only doing some conceptual sketch for you, but we're gonna see concrete example in just a moment. Let's return back to the slides. Okay, so now that's exactly what I said about the aliasing. So you can review the slide. It's have illustrated everything already. So that's the final outcome. Again, if you're not too sure about how to visualize this, please watch the recorded illustration to make sure you understand it. Finally, we're going to see the deep copy, the final one. You can think about deep copy is like the opposite of reference copy. In the case of reference copy, you got aliasing starting from the objects being copied themselves. So everywhere you got aliasing. However, for deep copy, it's similar to the composition idea that you learned from the previous object-oriented programming course. When you have deep copy, there should be no aliasing at any level. So consequently, the deep copy would have to be computationally the most expensive one among the three approaches to copying objects. Let's see. How do you write it? You're gonna write it like this. We still got our assignments structure over here, and now the right hand side, C2.deepTwin. C2.deepTwin is the expression for writing a deep copy for object C2. And how do we do that computationally? Imagine that you're going to define this process recursively, right? Because you have no idea. Let's say if you want to do a deep copy for C2, C2.A, remember what I said, is a cloud, which means C2.A can be arbitrarily complicated. If it's simply just one level of object structure, you just do one level of copying. However, if it contains 10 levels of object structure, you have to do 10 levels of copying in order to prevent aliasing. Well, we're going to see some example. Okay, so again, you have to create a brand new object. So this very first step for the deep copy is just the same as a shallow copy, right? So you're creating different objects to begin with. But now, remember the second step for shallow copy is you simply do reference copy, but it's not the case anymore, because in the deep copy we do not want aliasing. So what we want to do is recursively try to initialize the attribute A. Goes like this. Okay, so now base case would be if A is simply just primitive or is a single reference. If that's just primitive, let's say integer, then you will just do simple assignments, because that one there will just copy the integer or boolean. However, if C1.A is actually a reference type, which means it actually points to some cloud that's arbitrarily complicated, in that case, you can think about recursively, you're going to call the deep twin on C2.A. So now notice the difference here. In order to do C2.deepTwin, if we enter the recursive case, which means C2.A is actually complicated, you have to recursively call C2.A. So if the recursion goes like this, the only way we can make sure we don't run into infinite recursion is eventually the copy will reach a point where you only copy primitive values. Okay? It's just a little bit insight into the recursive process. We don't really have to implement the deep copy ourselves, fortunately, because IFO compiler does it for us, so we don't have to worry. But conceptually, you should know what it is really meant to do. Okay, let's now illustrate this deep copy here. Let's now move to here. Okay. Let's say for deep copy here, so this part over here is deep copy. And then let's see how we can do it. A very similar process. The first step will be the same as a shallow copy. So now behind the scene we got C3, which is pointing to a brand new object of type C. And then it's A over here. Let's put a question mark, just unknown, just for now. That's the first step. What about the second step? The second step, according to the definition, is going to be that C3.A is assigned to rather than a reference copy, which is the case for shallow copy. If we're going to write C2, right? That's an object we want to make a deep copy of, dot A dot deep twin. So this is the recursive part. But how can we visualize this? You can think about C2.A. C2.A is referring to this particular cloud over here. When we say we want to make a deep twin, conceptually, you can think about we just create another cloud. So now, what's going to happen is C1.A is simply just pointing to an identical cloud, but a completely separate objects. So now it's simply just a cloud. And then this one will just be C3.A. So now if you think about C3.A the cloud and also C2.A the cloud, these two clouds are structurally identical, but they're different objects. They're completely independent. Okay? And of course, we have to execute the assignments over here. C1 is assigned to this particular deep copy. So now C1, rather than pointing to here, is going to store the address of the deep copy. So now C1 is not going to point to wherever C3 is going to points to. Okay. Hopefully it makes sense. But now let's do our standard checks. First of all, let's try C1 equals C2. Afterwards, okay, it's quite obvious because the first step is just the same as a shallow copy, so they should be different. Let's just verify this. So C1 is now pointing to this particular deep copy object here, and C2 is pointing to this particular object, which is guaranteed to be different from the deep copy objects. So this first one here should be false. And notice that false is the consistent result as the false for a shallow copy, but different from the true in the reference copy. Right? I'm just trying to compare for you. Let's do one more. What if we try to say C1.A equals C2.A? In the case of reference and shallow copy, it will simply just be true. What about in the deep copy? Well, if the result would just be the same, that means we cannot distinguish. But let's see. Let's try this. First of all, C1.A. C1.A is actually referring to this particular independent cloud that we created, which has no aliasing, right? What about C2.A? C2.A is actually referring to this particular independent cloud. So the blue and the green, they are independent, so they are not the same. So if you do a reference comparison, they should be false. And notice that this false over here is different from the true. In the case of the shallow copy, of course, is also true in the case of the reference copy. Okay, so hopefully you really get the 3 levels of copy. So I think that these examples are really abstract, but I think it's really useful to really give you the mental intuition about how the 3 levels goes. And then before we see the concrete example, okay, let's now go back to the slides, and I believe everything is covered over here. And then that's the final outcome. Again, watch the recorded illustrations if you still have trouble understanding for the first time.